All right, we're back with section 3.1, the surface area of prisms, where you need to take a 3D shape, break it down into a net, identify the area, of all of the shapes, and add them up. It's nice when there's a shape like this and we get multiple areas that are the same. So let's head down to example 3.1.2. Nicholas ships posters and reproduction art prints to customers in shipping boxes made in the shape of an equilateral triangular prism. All right, that's a piece of information. It's nice to know. Equilateral triangle prism, as shown in the diagram. Draw a net, so we're trying to draw a net of the box and label the dimensions of each side. That's our first question. Then our second question is to calculate the surface area of the box. All right, so this is an equilateral triangular prism. So let's draw the net. All right, so we've got a triangle at one side. Then we have a long box to the other side. So what I'm drawing here is I'm drawing this triangle right here, and then this long rectangle here. And that's right here. I'm just trying to unfold this. Then we've got a triangle at the other end. Then we would have another rectangle here and another rectangle here. This would be unfolded, right? This rectangle here would be like this front rectangle here. This rectangle here would be like this back rectangle here. Now this is an equilateral triangle. That means all of these rectangles, this rectangle, and this rectangle will all be the same size. So let's now dimension it. Okay, so this is 15.2 centimeters right here. This is also 15.2 centimeters. And so is this third one, is also 15.2 centimeters. Oh, isn't that nice? It's 96.5 centimeters long. And the height of this triangle is 13.2 centimeters. Right, so this rectangle is the same size as this rectangle, is the same size as this rectangle. This triangle is the same size as that triangle. So that is letter A. Now, letter B, we need to calculate the surface area of the box. Now, I've got space on the next page. If you look on page 8, there's lots of space here to write more stuff out. It is the same box right here, but I feel that I've got enough space to work up here. Now, I'm going to do the triangles. The triangles I've highlighted in pink. So I've got two triangles. To figure out the area of a triangle, I do base times height divided by 2 and then times it by 2 because there's two of them. And for this triangle, my base is 15.2, right? That's that, 15.2. My height is 13.2. It's going to be 15.2 times 13.2 divided by 2 times 2. Now, this divide 2 and times 2 is going to cancel out. And I'm going to be able to just multiply those two numbers together. So I get out my trusty calculator. 15.2 times 13.2 is equal to 200.64. 200.64 centimeters squared. Now, moving on, and I hope I have enough space here, the rectangles. Well, there's 1, 2, 3 rectangles that are exactly the same. So I write out my formula. Area is equal to length times width, and there's 3 of them, so we times it by 3. Area is equal to 96.5 times 15.2 times 3. Now I'm getting a little bit tight on space here, you can see. But I just have one more step, right? 96.5 times 15.2 times 3. I use dots for multiplication. 96.5 times 15.2 times 3 is equal to 4,400.4 centimeters squared. So finally, we can find the area total. A sub t is equal to 200.64 plus 4,400.4 centimeters squared for a total area of 4,601.04 centimeters squared. And that is the total surface area of the box. Remember, when you're doing this, read the problem, identify the information you're given in the problem, identify what question you're trying to answer. Draw the picture, show all of your math work, identify your answer with the proper units. Everything should be laid out and easy to find. All right, so thank you.